Right, today year 8, so we're going to be looking at matter, okay? Now, don't worry about the 9 p.m. that's written on there, it's just the heading for this unit. Okay, so when we discuss matter, matter refers to everything around you. Anything that is made of particles, we refer to this as matter. So in particular, we're going to look at how particles behave. And by the end of this session, I am expecting you to be able to do the following things. First of all, describe the arrangement and motion of particles in a solid, liquid and gas. Define diffusion in terms of particle concentration and explain how temperature affects diffusion. And finally, explain why particles rearrange their order when they go from solid to liquid, liquid to gases, gases to liquids, in effect, change of state. Okay, before we start, as usual, we have a few things that we need to take care of. First of all, turn off your phone or put it in a different room. Secondly, don't have any other tabs open on your computer. Thirdly, answer all the questions. If needs be, you can pause the video, not a problem. Fourthly, you can always rewind and listen again if you are not sure. And finally, don't give up, guys, okay? If you give up, then you're not going to make progress. If you keep trying, there's a very, very, very good chance you will make progress. It will click. Now, since you have met particles when you were at primary school and possibly last year when you were in year 7, I just want to do a quick recap. So, all you need to do here is look at the particle arrangements for solids, liquids and gases and fill in the blank boxes. Okay, so for example, on a separate piece of paper, write down the arrangement of, or describe the arrangement of particles in solids, gases, then describe the movement of particles in liquids, gases, and so on and so forth. Do pause the video. Get yourself a green pen and assess your work. Pause the video if you need to. Now, the arrangement of particles and how they behave in different states explains a lot of phenomena that we experience, everyday phenomena. So, for example, one question, why can you smell breakfast cooking from upstairs? So you're upstairs, someone's cooking breakfast downstairs. Why or how do you know that they're cooking? Why does that smell drift upwards? So have a think. What happens is that particles in a gas, they move around. They move around by diffusion. Diffusion is where you have a high concentration of gases in an area, and what gases tend to do is they tend to spread out. So this gas will go from an area of high concentration to an area of low concentration, and this is called diffusion. Okay, diffusion is the spreading out of particles from an area where there are lots of it to an area where there are less of it. Watch this little video. It's a nice little demonstration of how diffusion does take place. So what you have is a solid particle which has, well, purple coloured particles if you will. You put it into water and the particle will spread out and you end up with a purple solution. This is a classic example of diffusion, and it is a demonstration that many teachers will show or demonstrate in a classroom. Just a reminder, remember that particles in liquids and gases, they can move around, and they do move around. The movement of a substance through a liquid or gas from an area of high concentration to an area of low concentration is called diffusion. So diffusion can take place in liquids, it can take place in gases as long as the particles can move around. So that means diffusion cannot take place in solids, because in solids the particles cannot move around. They are in fixed positions. Okay, let's get our thinking caps on. We know what diffusion is. We know it happens in solids, liquids and gases. The question is, I want you to write a conclusion, okay? In which phase, the solid, the liquid or the gas phase, does diffusion take place the quickest? I want you to explain your answer using your idea of particles and their movement. Pause the video and do this now. We know what diffusion is, we know how it works. We're now going to see whether temperature affects the rate of diffusion, and if it does, why and how. So if you look at this diagram, you can see two potassium permanganate water to become solutions. One is hot, where the temperature is hotter, and one is in cold water. So, what is happening and why? Pause the video now, and then after you've had your thinking time, turn it back on. Okay, so it's obvious, well, it looks obvious to us. In the hot water, diffusion is happening or taking place quicker. Cold water, diffusion takes place lower. So, to conclude, the higher the temperature, the quicker the rate of diffusion. Why is that? Basically, the particles in water, the particles in the potassium permanganate or the purple solid, the hotter they are, the more energy they have, the more they move around. So if they move around faster, diffusion will happen faster. That is it. So as you can see in the diagram, when you have solids, solids particles are arranged in order. They are not moving around, they're in fixed positions. If you give them enough energy, the particles will overcome the forces of attraction between them, and the solid becomes liquid, and the liquid particles are now moving around. Okay? If you give the liquid particles even more energy, the liquid will get hotter, the particles will have more energy, they'll move around a lot more until they break away, they overcome the force of attraction and break away from each other. Now the particles and gases are moving around really, really fast. So I want you to write a conclusion. See the sentences on the PowerPoint. There you start sentences, so complete them. Okay? So diffusion happens, fastest in, complete the sentence. And do the same for the second one. The second sentence is your explanation. This is because, and whatever you think it is. Okay, so pause the video and do that now. Thank you. Using the mark scheme that you are now looking at provided, assess your work in green. And pay particular attention to the points underlined. Now then, I love these questions, okay? So look at the questions, and what I want you to do is pause the video and think about the answer to each of these questions, and just jot it down, you know? Just have a think and jot it down. To answer the questions before, basically, all you need to do is just think about how the particles move. Remember this one little fact. When particles gain energy, they will start to vibrate initially, if they're in solids, vibrate, they overcome forces of attraction between themselves and other particles, they start to move around, they get more energy, they move around even more, and when particles move around more, their movement gets faster. That's all you have to do. So, when we heat substances, they often expand. The particles themselves don't expand, okay? The particles do not change size. What happens instead is the gaps between, or the spaces between the particles will increase because the particles are gaining energy. And as a result, we say the material becomes less dense. Remember, density is the number of particles in a volume of space. So the next question is, what happens if we add more heat? Well, if you add enough heat to a solid, then the particles will gain enough kinetic energy to break away from the attractive forces holding them together. What this means is the solid will then start to melt. Think about it. You've got a lump of ice, sunshine starts shining, the lump of ice it gains, well, thermal energy, heat energy from the sun, and it starts to melt because the particles inside the lump of ice, the water particles inside the lump of ice, are vibrating a lot more violently until the attractive forces are overcome. What we say is that there has been a change of state. Okay, you have a solid state, liquid state, and a gas state. Some people call these states phases. A change of state often occurs when energy is lost by the particles or gained by the particles, and this is often enough to cause a change of state from one state to another. So if you look at the diagram below, or well, I say below, on the PowerPoint/video, can you name these different states? Okay? Sorry, not states, I meant state changes. Sorry, my mistake. Alright, so we've got state change 1, 2, 3, 4, 5. There is a sixth one, but we don't really need to worry about this at this stage. To do this now. Now this is just a little diagram. What it shows you is what happens to the temperature of particles as energy is added. So, if you look on the left hand side, the y-axis, this shows you temperature. If you look at the bottom axis, the horizontal axis, the x-axis, this shows you energy transferred. So let's just follow the green line for now. Okay. As we increase the amount of energy, so if we increase the energy, the green line is obviously travelling towards the right, but it's also going up, which means the temperature is going up. So as the energy increases, the temperature increases. That makes sense. So a solid, you keep heating it, you keep giving it energy, the temperature will increase until it starts to melt. When it starts to melt, something interesting happens. The energy is still increasing, but look, this is a horizontal line. The gradient, or the slope, is flat. So the temperature is increasing, but the energy is increasing, but the temperature is not. This is melting. Okay? So when something melts, there is no change in temperature. Once all the solid has melted, become a liquid, what you'll then find is, if you keep increasing energy, the temperature starts to rise again. So it will do that, keep adding energy, temperature of the water, in our case water, will increase, until suddenly it starts to boil. Boiling is where liquid turns into gas. What you'll notice is, we're still giving energy to the liquid, but the temperature no longer increases. The gradient, the slope, is flat. So, what this tells us is, when things melt or when things boil, the energy is increasing, but the temperature does not change. Once all the liquid has turned to gas, then obviously the temperature of gas will just increase and increase and increase. Okay, just to recap. When you increase the energy of particles, their movement increases, their temperature increases. And as their movement increases, they overcome forces of attraction between particles. However, if you do the reverse, if you decrease the amount of energy or remove the energy from the particles, the movement will decrease, and as a result the temperature will decrease, and forces of attraction between the particles will clump them together. Okay, so I'm just going to repeat what I've said earlier. Particles gain energy as they get hotter. As they gain energy, they move faster. At the boiling point, the speed of the movement has enough energy to break free from the force of attraction between the particles. The energy is breaking the forces of attraction okay, and not making the particles move when there is a state change, okay? So when something is melting or when something is boiling, the energy is not being used to make the particle move faster, it's being used to break the force of attraction between particles. Only when melting and boiling take place. Pause the video and answer these questions, okay? These questions are on our basic task 4 on the student booklet. Use this slide to assess your answers. Right, here's a quick bit of, it's a bit of a practice you can do at home. So pause the video, do it, and then unpause the video and I'll explain to you what's going on. Okay, so I'm assuming you have had a go at this. What happens is, when you're adding energy to solids, you make it heat up and it will eventually melt. Okay, so metals are good conductors of heat, whereas plastics are actually very poor conductors. So metal is able to transfer energy to the ice cube a lot quicker than the plastic. Hence the reason why the ice cube on the metal melts much faster.